when we say raw materials of the rubber, it is the primary source or the original source of forming a rubber. So the first one is the thermoplastics. So thermoplastics is used in conjunction with other polymers and other chemicals. And it is used in a relatively pure state, which is contributes to a further guide of recycling. So under thermoplastic polymers ay also polymers. So it is used on their own, such as like polyethylene, polypropylene, and polystyrene, which is relatively easy to recycle and may repeat a number of times without undue deterioration. So other type of thermoplastic polymers is blended and compounded polymers. So here it is less stable and more liable to deterioration during recycling. Some examples are like PVC and ABS. So ABS is acrylonitrile butadiene styrene. So supplementations may made to polymers to improve stability, but it is also expensive and used very sparingly. So next one is Thermoset Polymers. So Thermoset Polymers, it is implied thermoset plastics. So it is distinguished by the fact that during process they are cured and form 3D networks. So it is described as long thin molecules laid in a random manner but no firm bond between the molecules. During the curing process, it is a state which permanent bonds are made at numerous points in the chain with other molecules. So, next one is rubber. So rubber is regarded as thermosets. So may process na until it is vulcanized, it becomes largely thermoplastic that may physically reshape without major loss of properties. So So next one is natural rubber. Natural rubber is a material that comes from trees and some extent. So it's a regenerating raw material. Example nito ay yung latex. So next one is synthetic rubber. Synthetic rubber comes from oils in any various forms. So it is also dependent upon reserves of oil. Then it is tailored to provide particular properties such as oil resistance, flexibility at extremes of temperature, resistance to ozone, and also it cannot be regarded as capable of replacement by natural rubbers. Although synthetics can be used in place of natural. So lastly is the compounding ingredients. So compounding ingredients, it is optimum properties of polymers that are obtained by compounding both of other polymers with mineral fillers. It is also very wide range of properties that are obtained by large variety of compounding ingredients. So some examples of compounding ingredients I am PVC. Possible to make, it is either a flexible sheet by clothing and packaging, and also a rigid material from building applications, drainage piping, guttering, etc. Other kinds of compounding ingredients are thermosets. Thermosets are compounded with paper, mica, glaze, marble, and flour. Rubber compounds more complex. Polymer and filler is added small percentages of chemicals, and it is designed to assist control the vulcanization process and provide resistance from the ozone.
Now, let's go to rubber manufacturing processes on how the rubber is processing. Rubber, whether natural or synthetic, arrives at processor, fabricator, plants in large bales. Once the rubber arrives at the factory, processing goes through 4 steps. First step is compounding, then mixing, then the raw materials will go shaping, then the last part is vulcanizing, step 1. The rubber compounding formulation and method depends on the intended outcome of the rubber fabrication process. Now let's go to the step 1. Let us discuss and see how the rubber is formed. Let's go to step 1, compounding. Next slide. Compounding. As you can see in the GIF picture, Here, compounding adds chemicals and other additives to customize the rubber for the intended use. Natural rubber changes with temperature, becoming brittle with cold and sticky glue-away mess. With heat, chemicals added during compounding react with the rubber during the vulcanizing process to stabilize the rubber polymers. Additional additives may include reinforcing filters to enhance the properties of the rubber or non-reinforcing fillers to extend the rubber, which reduces the cost. The kind of filler used depends on the final products. This is the reason why the rubber materials has a high modulus of elasticity. It because of its raw materials, it because of its traits, its tawag dito, yung natural habit niya. Kaya yung modulus of elasticity when it comes to stress. The most commonly used reinforcing filler is carbon black. Derived from soot, carbon black increases rubber's tensile strength and resistance to abrasion and tearing. Carbon black also improves rubber's resistance to ultraviolet degradation. Most rubber products are black because of the carbon black filler. Depending on the planned use of the rubber, other additives used could include anhydrous aluminum, silicates as reinforcing fillers. Other polymers recycled rubber, usually less than 10%. Fatigue, reducing compounds, antioxidants, also chemicals, and coloring pigments, plasticizers, softening oils, and mold release compounds. Now let's step 2, mixing. Next slide. Yan, mixing. As you can see in the picture, it's nice. It's nice. The additives must be thoroughly mixed into the rubber. The high viscosity, resistance to flow of the rubber makes mixing difficult to accomplish without raising the temperature of the rubber high enough to 300 degrees Fahrenheit to cause vulcanization. To prevent premature vulcanization, the mixing usually takes place in two stages. During the first stage, additives like carbon black are mixed into the rubber. This mixture is referred to as master batch. Once the rubber has cooled, the chemicals for vulcanization are added and mixed into the rubber. Next slide. Step 3, shaping. Shaping rubber products occurs using four general techniques: extrusion, calendering, coating, or molding, and casting. In this case, the mold has been used to shape the raw materials. It becomes rubber, as you can see in the GIF. More than one shaping technique may be used, depending on the final product. Extrusion consists of forcing highly plastic rubber through a series of screw extruders. Calendering passes the rubber through a series of increasingly smaller gaps between rollers. The roller die process combines extrusion and calendering produces a better product than either individual process. Coating uses a calendering process to apply a coat rubber or to force rubber into fabric or other material. Like example of the rubber materials is that has been fabricated: tires, yan, gulong, waterproof cloth, tents, and raincoats, yung mga kapote, example of rubbers. Conveyor belts as well as inflatable straps are made by coating materials with rubber. Rubber products like shoe soles and heels, mga sapatos, gasket seals, suction cups, and bottle stops are cased using molds. Molding is also a step in making tires. The three primary methods of molding rubber are compression molding, yan baka lumabas sa exam to, is used in making tires among other products, transfer molding, and injection molding. Vulcanization of the rubber occurs during the molding process. rather than a separate step. And the final step is, next slide, vulcanization. Yan, vulcanization process. Vulcanization completes the rubber production process. Vulcanization creates the cross connection between the polymers of rubber, and the process varies depending on the requirements of the final rubber product. Fewer connection between the rubber polymers creates a softer, more pliable rubber, increasing the number of cross connection, decreases the elasticity of the rubber, resulting in the harder rubber. Without vulcanization, rubber would remain sticky when hot and brittle when cold, and it would not budge more quickly. In short term, vulcanization, without the vulcanization, the raw materials will remain sticky and it will not form a solid rubber. Kung wala kung wala yung vulcanization, magiging sticky lang yung raw materials. Hindi siya mabubuo. Hindi mabubuo yung gulong, hindi mabubuo yung mga ibang example, mga raincoats. Yan. Kaya vulcanization is very important in making rubber. Next slide. Oh, na dots. Toots.
Di pa ata nakakapasok eh.
Paano yan? Ikaw na rin magre-report
Hello?
na
Hello? Dinig niyo ba
Ikaw na,
ako?
Toots. Dinig ka, dinig.
Hello? Nico?
Okay,
Nel? Ronel?
okay, good. Okay. Sige.
Hello? Dinig ba ako?
Oh, okay na, okay.
Hello?
Okay na nga.
Oh, pre, rinig ka.
Okay. Yung slide di ko
Dinig na
makita.
dinig ka, sa kabilang bahay.
Di ko makita yung slide. Ang bagal ng data.
Sabihin ko na lang, properties of rubber.
Okay.
Huwag kami
Plastic, Nico. Ay, dots.
Ayan. Ayan, nakita ko na.
Elastic na, dudes.
Sige, sige. Thank you, Nel.
Okay na.
Rubber, it is elastic because of this property. A rubber band can be stretched to 9 or 10 times its original length, and when the load is removed, it regains its original length. It's one of the properties that rubber has. And next, for its hardness, it is strong and tough. Because of this property, it can be put to use even under abnormal conditions. And sometimes it is highly impermeable to both water and air, and therefore it can be used to retain water, as in rubber bottles, hoses, and etc. Next, for the next properties is contraction. Its properties such as hardness, strength, abrasions, resistance can be modified to the desired extent by compounding techniques. And the plasticity of rubber makes it pliable and amenable to all manufacturing process. By vulcanizing the rubber, its mechanical properties can be considerably improved. For rubber insulation and other rubber products require shaping prior to vulcanization because the vulcanized rubber cannot be shaped by mechanical pressing once it has acquired its characteristic plasticity. Although rubber is practically water and gas tight, its electrical characteristics are affected by moisture, especially for rubbers, compounded with considerable quantities of the substances, which increase the sensitivity to moisture. Next. For the advantages and disadvantages of rubber, next. So I will tackle four types of the advantages and disadvantages of rubbers. So the first one is latex. For the advantages, latex is ready to use right out of the container, and latex is inexpensive. It exhibits good abrasion resistance and is an elastic mold rubber. Because of its high elasticity, a feature unique to latex is its ability to be removed from a model like a glove. Latex molds are also good for casting wax and gypsum. And for the advantages of this type of rubbers is it has a low cost product. Latex products generally shrink, and making molds with latex rubber is low and time consuming. The next type is next, Nico. Next. Next. Ayun. Thank you. Po- Polysulfide rubber. For its advantages, polysulfide molds are very soft and stretchy and long lasting, some when lasting 40 years old. And it is good for making molds with severe undercuts or very fine details. And for the disadvantages of this kind of rubber, it has offensive odor, and polysulfides must be mixed accurately by weight or they will not work. Polysulfide rubber costs higher than latex. Next. For the next kind is silicone rubbers. The advantages of this type is silicone rubber has the best release properties of all the mold rubbers, and the combination of good release properties, chemical resistance, and heat resistance makes silicone the best choice for production casting of resins. And the disadvantages of this kind of rubber is silicones are generally high in cost, and they are also sensitive to substances and do not have a long library life. The next one is polyurethane rubbers. For its advantages, polyurethanes are easy to use with many having a simple mix ratio by volume, and they are less expensive than silicones and polysulfides. And the disadvantages of this type of rubber is a silicone rubber has the best release properties. Urethane rubber has the worst release properties, and it will adhere to just about anything, and it is limited shelf life after opening. Remaining product may be affected by ambient moisture in the air. Next, rubber application. Kanina na yan, Nel.
Receive. Receive yan.
Seb?
Bastian. Seb.
Hello? Hello? Rinig ako?
Oo na. Oo na.
Rinig ako?
Okay na, dinig ka na.
Okay. Rubber components for engineering applications. So, why rubber is important? Next slide. Natural rubber is used in applications requiring high level and wear and heat resistance. Thanks to its strength and compressibility, natural rubber is used in engineering applications. So, anti-vibration mounts. Anti-vibration mounts, also known as AV mounts, are the key components in reducing noise and vibration in heavy machineries and equipments. So, we all know that in the use of this, we are reducing the noise and the vibration caused by the machine. Next. So, drive couplings. Drive couplings are power transmission components used to couple the shafts of various mechanical devices. So, drive couplings can be used in compensating for the shaft misalignment. So, ayan. Usually, ginagamit siya for making shaft combination. Next. So, rubber spring or spring rubbers. Spring rubbers are a quick, low-cost way of spring rate changes. By adding rubbers, you increase the spring rate, and as you eliminate the effects of one or more coils. So next, bearings. So bearings are part are parts that assist objects rotation, that supports the shaft and that rotate inside a machinery. So we are familiar with that naman kasi. So next. So adhesives. So yun lang. Adhesives, any substance that is capable of holding the material together in a functional matter by surface attachment that resist separation, adhesives. So made of plastic. So yeah.
Tapos na. Shirley.
Surely na lang wala.
Seb, nakita mo si Lebron? Nagtatwerk na naman. Ayan si Shirley, Nico.
Hindi ata makakonect si Shirley.
Naririnig niyo na ako? Hello?
Hindi, tapos na.
Oo.
Hello?
Oh, naririnig ka na.
Tapos na, Seb.
Okay na. Ito na.
Andiyan na, Shirley.
Ay,
Ayan, okay na, okay na.
Okay na. Sige.
introduction na sa uli, no?
Sorry po, nawalan ako ng internet.
Okay lang, go,
So,
go.
okay na. So, doon tayo sa UNAT. So, tapos na sila mag-explain about sa process, application, and raw materials. So, doon po tayo sa history niya. So, rubber, where does it come from? So, rubber is a natural product produced by plants and is present in many good use in our daily lives. Rubber has an important role in human history. So, what is a rubber? So, a rubber is a material that can be stretched and will retract rapidly and forcibly to substantially its original dimensions upon release of the pores. So, next slide, please. So, timeline, so history, so development of rubber. So, Mayan people are considered as the people to discover and use rubber. So, Mayan people is people which situated in Mexico and Central America. So, in 1736, rubber was introduced in France. In 1770, the discoverer of oxygen, English scientist Joseph Priestley, finds he can use pieces of rubber to erase the marks made by pencil and paper. In England, erasers are still widely called rubbers today. So in 1791, Englishman Samuel Peel develops a method of waterproofing cloth with a rubber solution. Next slide. So, in 1839, American inventor Charles Goodyear developed the vulcanization heat treatment process that makes rubber harder and more durable. So, vulcanization is a process of treating rubber with sulfur and heat to harden it while keeping its elasticity. So, in 1879, first synthetic rubber was made in laboratory. In 1910, first commercial synthetic rubber was produced. So in 1931, first successful synthetic rubber was manufactured. And in 1940, synthetic rubbers are produced in the United States for the time by companies such as Firestone, Goodyear, and Goodrich. Next slide. So there are two types of rubber. So this is the natural rubber and synthetic rubber. So natural rubber is made from a runny, milky white liquid called latex. So latex is a whitish milky containing proteins, starch, alkaloids, and etc. that is produced by many plants. In some plants, it is called rubber. So, and then the next one is the synthetic rubber. Synthetic rubbers are made in chemical plants using photochemical as their starting point. So synthetic is actually a man-made rubber that can be produced through a chemical process. So, but people have not been able to produce synthetic rubber that has all the properties of natural rubber. So, natural rubber cannot be replaced by a synthetic rubber in most of its application. This is why natural rubber is still very important to human society. So that's all our report. Thank you for listening.